Alright, now we have more sample spaces. A table's really good, but a tree is good when you have choices. And the tree is another nice way of kind of figuring things out. Now, here's an example of when you would want to use a tree. You go to a sandwich store, sandwich shop. It has 3 different breads you can choose from, 4 meats, 3 cheeses, and let's say 5 vegetables. And that's what you can choose from. So you have all these different choices. And now for 3 breads, we can say like B1, B2, B3. Now when you're building this, it's sometimes easier when you have multiple choices like this, and they're going to be a little bit more, this one's going to end up being pretty big. But here's the idea. You get 3 choices. Your first choice would be, like, for example, if you take bread 1, bread 2, and bread 3 is all the way down there. Now with bread 1, after you choose the number of bread, how many meats can you choose? 4. So that's M1, M2, M3, and M4. So you're going to branch out from everything with each individual choice. So this is second choice. There's going to be 3 cheeses. Do you see the problem that comes up with this?
That's a lot of choice. We still need to do the other 2 breads.
And then there's 5 vegetables. Why don't we just change that to 2 vegetables? And then you'd have 2 that branch off from there, and 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 there. That's V1, V2, V1, V2, V1, V2, V1, V2, V1, V2, V1, V2, V1, V2. Not it. Now, like I said, trees are good if you have limited number of choices, but this is the idea. We would have to make a second one for B2 and a second one for B3. But at the end, we can count up. If you have the first bread, first meat, first cheese, and first vegetable, that counts as one total sandwich.
What if they just want, like, meat?
Well, you have to place, when you do a problem like this, you have to place some type of limitation on what they can choose. An easier version of this is, let's say You roll a 6-sided die and you flip a coin. Now, I would say do the coin first. What are the outcomes for the coin? Well, what types of outcomes? One's heads, one's tails. Now, say you flipped the coin, ended up on tails, and now you have to roll a die. How many different outcomes are with the die? There's 6. So it's going to be 1, 2, 3, 4, 5, 6. Same thing with tails. 1, 2, 3, 4, 5, 6. This is what a tree diagram gives you. So there's the coin. Now, what this means is heads and you rolled a 1. This is heads, you rolled a 2. Heads, you rolled a 3. Heads, you rolled a 4. Heads, you rolled a 5. Heads, you rolled a 6. Then we can ask a bunch of different questions. For example, how many total outcomes are there? How many different outcomes if I flip the coin, we got heads, and how many different outcomes were there? 1, 2, 3, 4, 5, 6. 6 outcomes from here. All you have to do is count up the number of outcomes on your last choice. So there's 6 from heads. How many from tails? 6. So there's 12 total. How about the probability that we flipped, we got heads and an even number? Well, how many total are there? There's 12 totals. How many answers? Well, if we flip the coins and we got heads, we're up in this branch. How many of those numbers are even? 3. So 3 out of 12. Another good one that you'll see is this. Flip 3 coins. Now, everybody draw the tree diagram for flipping 3 coins. Do the first flip, then the second flip, and then the third flip. I give you about 30 seconds because it shouldn't take you too much longer than that. You'll see in 1 second. Alright, on the count of 3, I'm going to open it up. 1, 2, 3. First flip, heads and tails. If I flip heads the first time, I'm going to flip a coin a second time, and it can only land on heads and tails. If I got heads a second time and I flip it the third time, I can only get heads and tails. And same thing here. If I got tails the second time, it can only be heads and tails when I flip it the third time. And same thing here. If I got tails, I flip it again, get heads and tails. Then if I got heads a second time, flip it, heads and tails. If I got tails, same thing, heads and tails. So we have a nice little sample space. What's the total outcomes? There's 1, 2, 3, 4, 5, 6, 7, 8 outcomes. There's 8. We can list them too. Heads, heads, heads. Heads, heads, tails. So we follow the path. Heads to heads to heads. Heads to heads to tails. Heads to tails to heads. Or heads to tails to tails. And then we do the same thing over here. Tails to heads to heads. So we follow that path. Tails, heads, tails. Tails, tails, heads. And tails, tails, tails. Now let me ask you this. What's the probability that you get at least 2 tails? Now, once you have your sample space, you can go and say, all right, take a look at that first guy. Are there 2 tails in that one? No. Is there at least 2 tails in this one? No. At least 2 tails in this one? At least 2 tails in that one? All right, so we got 1. Here's where your fingers work really good. 2 tails in this one. 2 tails in this one. Alright, so that's another one. 2 tails in this one. Alright, that's another one. Do I have at least 2 tails in this one? I have 3, but all I asked for was at least 2. So that's 2 or more. So I have a total of 4 out of 12. No, 4 out of 8. Because there were 8 outcomes. I was thinking the other one. So I have 4 out of 8. If I said the probability of only 2 tails, there's 8 total. How many only have 2 tails? 1, 2, 3. 3 of them. So you got to be really careful about how things are worded.